Neurological recovery is the active, physical process of forging entirely new detours around the damaged areas of your brain. The brain cannot simply wait for time to heal the injury. It requires a deliberate structural rewiring of its own infrastructure. This rebuilding process hinges on a single biological prerequisite, a concept known as massed practice. For the brain to take these new routes, a person must execute an incredibly high volume of repetitive actions every single day. Thousands of successful repetitions are required to move the needle. In this environment, human stamina becomes the ultimate bottleneck for healing. When recovery is reduced to clinical drills, every failed repetition becomes a source of mounting frustration. That frustration eventually triggers a severe internal stress response, the amygdala hijack. Shame and panic act as chemical triggers, flooding the nervous system with cortisol and adrenaline as the body enters fight or flight. This reaction physically diverts critical blood flow away from the prefrontal cortex. By rushing, the patient starves the very region needed for neuroplasticity. It's a biological catch-22. The more a patient tries forcing the repetitions required to heal, the more the nervous system locks up and prevents that progress from happening. Rehabilitation specialists bypass this bottleneck by shifting into a new lane, an environment that removes the high-stakes pressure of a clinical setting. In this space, the operational rule changes. The brain focuses on accuracy and grace rather than speed and panic. Specialists create this low-pressure environment using interactive puzzles and structured narrative play. Gamification solves the repetition problem by disguising the work. The patient stops counting reps and starts focusing on the objective. Navigating an interactive challenge forces the brain to perform hundreds of visual scans and micro-decisions without the mental fatigue that usually follows clinical drills. Play serves as a biological camouflage, allowing the brain to endure the high volume of work necessary for recovery without triggering cognitive burnout. In a traditional drill, an error feels like a medical setback. In a game, an error is simply the start of the next turn. Because the mistake is framed as part of the loop, the brain's alarm system remains dormant, keeping the pathways to the prefrontal cortex open. When a player resolves a pattern or reaches a target, the brain releases a specific chemical reward, dopamine. Biologically, dopamine functions as the primary neurotransmitter for memory formation and sustained attention. It provides the signal needed to physically thicken and solidify new neural connections. Gamified play supplies the exact chemical reinforcement required to turn a temporary repetition into a permanent neural detour. Narrative frameworks like the Obsidian Drop provide a concrete structure for patients to engage in this high-volume, low-stress cognitive work. The mechanics are designed to train specific functions, such as using visual field scanning to identify subtle environmental patterns. Logic-based challenges require the prefrontal circuits to hold and manipulate multiple variables, which directly strengthens working memory. Using a dedicated scratchpad shifts the focus away from the clock. The effort spent working through the problem is more significant for the brain than the final answer. This shift in focus allows the patient to stop being a passive recipient of therapy and start acting as the lead developer of their own cognitive recovery. These biological hacks only reach their full potential when paired with an emotional shift toward radical acceptance. This means standing on your current baseline without apology, focusing on the new lane you are in today, rather than the tempo of the past. When you stop trying to match an old pace, you stop the amygdala hijack before it starts, conserving the cognitive energy that would otherwise be lost to stress. Prioritizing accuracy before speed creates the specific chemical and emotional safety the nervous system needs to fire cleanly. By replacing the grind of clinical drills with the engagement of low-stakes play, patients can finally provide their brains with the environment required to rebuild.